In today's lesson, we'll focus on the micrometer, sometimes referred to as a mic. Micrometers are often used when specifications require more precise measurements than can be made with a steel rule. The mic is also a much more complex instrument than a rule. It is a mechanical device with adjustable operating parts and several sets of scales which use either the decimal inch or the metric system. You should know the names and uses of each of these after this lesson. The mechanical mic is an extremely important tool. More sophisticated versions of the mic, such as the optical micrometer, utilize many of the same features and measuring concepts as the basic mic we'll be reading today. The skill developed in using the basic micrometer can be applied broadly to advanced equipment, as we'll see in our final lesson. There are two types of the standard micrometer: the outside mic and the depth mic. Their names indicate the kinds of dimensions they measure. Today, we'll concentrate on taking readings with the most common mic, the outside micrometer. Then we'll see how depth mics differ from outside mics in the way you read measurements. A diagram of an outside mic is shown in your study guide. This micrometer will measure in decimal inches down to tenths of thousandths of an inch, or tenths as they are often called. In use, the outside mic is normally held in the right hand. Holding the object to be measured in the left hand, place it between the anvil, which is the fixed measuring surface, and the spindle, the adjustable measuring surface. This is called the barrel, or sleeve. Most outside mics have two scales on the sleeve. One scale is always found on standard mics. Called the barrel scale, it indicates hundred thousandths of an inch, with increments of 25 thousandths. Another scale, located on top of the barrel and found on many outside mics, is the vernier. It indicates measurements of less than 1,000th. This is the thimble. It has an additional scale, the thimble scale, indicating thousandths of an inch. Turning the thimble with the thumb and the index finger adjusts the spindle against the object being measured by means of a highly accurate screw shaft within the sleeve. First, rotate the thimble so that the mic spindle and anvil surfaces snugly grip the object being measured between them. Never set the micrometer too tightly. Not only could this produce inaccurate measurements, but it could damage the micrometer or break the object being measured. At this point, make certain that the object is squarely against the measuring surfaces, the anvil and the spindle. Rock the mic slightly back and forth on the surfaces of the object if necessary. Then use the knurled end of the thimble to finish securing the object. It is either a spring-loaded stop or a ratchet stop. The stop is designed to prevent too much pressure from being applied to the object being measured. The spring-loaded stop spins free when adequate pressure has been applied. The ratchet stop clicks when correct pressure is applied. Turn it slowly and evenly. Too much force or speed can throw the measurement off. A spindle lock, operated either by a lever, knob, or lock nut, keeps the spindle in place to hold the measurement, allowing the object to be removed from the mic. The first reading on a mic is along the reference line of the barrel scale. The micrometer barrel scale is divided into 10 major numbered divisions per inch, each of which is 1/10 of an inch. These divisions are read in increments of 100 thousandths of an inch. Each major division, or 100 thousandths, is further divided into 4 minor divisions shown by these lines. Each of them represents 25 thousandths. The slightly larger line in the middle represents half of the 100 thousandths increment, or 50 thousandths. The next is 75 thousandths, and then the next 100 thousandths value is read. The thimble is turned, adjusting the spindle against the object to be measured. The measurement is indicated by the number shown at the edge of the thimble here. For example, this reading is 700 thousandths. Here, the edge of the thimble indicates a reading on the sleeve of the micrometer of 200 thousandths. Often, however, the edge of the thimble does not line up precisely on a number on the barrel scale. Then there is an additional step in taking what is called the total barrel scale reading. After you have determined the largest number or major division visible above the reference line on the barrel scale, you need to note the minor division line visible on the sleeve between the number shown and the edge of the thimble. Remember, each division below the reference line equals 25 thousandths. To determine the reading, simply add the largest number visible to the value indicated by the minor division line. For example, the barrel scale reading shown here is 400 thousandths plus 25 thousandths. So the measurement for this object is 425 thousandths. Here's another mic measurement to read. As you can see, the edge of the thimble comes to this graduation on the barrel scale. This mark is 3 divisions, or 75 thousandths, past the 800 thousandths mark. Adding 800 thousandths plus 75 thousandths will get a total barrel scale reading of 875 thousandths. Measurements to 1,000th can be taken by reading the scale on the thimble. Each division on the thimble equals 1,000th of an inch. Rotating the thimble 1 complete turn moves it 1 minor division on the barrel scale, or 25 thousandths of an inch. To read the thimble scale, note which graduation on the thimble lines up with the barrel reference line. For example, this setting reads 3 thousandths, about the thickness of a human hair. Let's take a look at this micrometer measurement. The 19 thousandths mark is positioned at the reference line, so the thimble scale reads 19 thousandths. This value is then added to the measurement obtained from the barrel scale. In this case, the barrel scale reads 250 thousandths. Adding to this value the 19 thousandths indicated on the thimble scale, we get a quite accurate measurement of 269 thousandths. So, to read the micrometer to an accuracy of 1,000th of an inch, first, determine the largest number visible on the barrel scale. Each numbered division is 100 thousandths. In this case, the reading is 700 thousandths. Next, read the divisions visible on the barrel scale between that number and the edge of the thimble. Here, 25 thousandths is indicated. Then read the graduation on the thimble that coincides with the reference line. Finally, add these all up. 700 thousandths plus 25 thousandths plus 11 thousandths is 736 thousandths of an inch. The reading on this mic is 428 thousandths. The barrel scale reading is 400 thousandths plus 25 thousandths. The thimble scale lines up with the reference line at 3 thousandths. 400 plus 25 plus 3 is 428 thousandths. However, when a graduation on the thimble scale does not line up exactly with the barrel scale reference line, a measurement between thousandths of an inch is indicated. In that case, we record the lowest of the 2 thimble scale graduations. Then we have to use a third scale that you see here, which is a feature of many outside mics, the vernier scale. Located on top of the sleeve, the vernier scale has graduations that allow readings down to tenths of a thousandth of an inch, or tenths. On this micrometer, the vernier consists of 10 divisions engraved on the barrel. Each division represents 1/10. Because you need to use the vernier scale only when measurements fall between thousandths on the thimble scale, you read the vernier scale last. To read the vernier, we first locate the thimble division line that precisely coincides with the graduation on the vernier scale. and read that vernier number. Remember, read the tenths number from the vernier scale and never from the thimble. For example, the vernier scale lines up with this graduation on the thimble. This is the 5/10 line of the vernier scale. In this case, we can see that 2/10 is the only graduation on the vernier scale which lines up exactly with the division on the thimble scale. So the measurement is 2/10. How many 10,000ths of an inch are being indicated on this vernier scale measurement? Note that the vernier line that coincides with the thimble division is the 3/10 line. The correct reading is 3/10 or 3/10,000ths, which is written 0.0003. Now let's review how all of these steps go together as we take measurements accurate to 10,000ths of an inch. The object to be measured is placed between the measuring surfaces of the mic. The thimble and the stop are then adjusted until the spindle is firmly secured against the object. To take the reading, first note the highest number visible on the barrel scale and determine how many 100,000ths it represents. Then determine the number of additional line divisions visible to obtain the total barrel reading. In this case, 800,000ths is visible, plus 3 additional 25,000ths graduations, which indicates an additional 75,000ths. Next, note the number on the thimble that is directly below the barrel scale's reference line. This number of thousandths is added to the value read from the barrel scale markings. Here, the thimble indicates 12 thousandths. So 875 thousandths from the barrel scale reading plus 12 thousandths from the thimble equals 887 thousandths. Since the thimble scale measurement falls between the thousandths divisions, a vernier scale reading is required. The vernier marking representing 10,000ths of an inch that lines up with the division line on the thimble scale is noted. This number of tenths is then added to the total of readings from the barrel and thimble scales. In this case, the graduation on the vernier scale that lines up exactly with the division line on the thimble scale is 6/10. Now we add this to the sum we obtain from adding the barrel and thimble scale readings. 875 thousandths on the barrel, plus 12 thousandths on the thimble, plus 6/10 on the vernier, produces a reading of 887 thousandths and 6/10. Look carefully at this micrometer measurement. Including the vernier scale indication, what is the total measurement? The highest number on the barrel scale is 5. The divisions on the barrel scale indicate 50. The thimble reading shows 6. And the vernier scale lines up on the 7. 500 thousandths plus 50 thousandths plus 6 thousandths plus 7/10 equals 556 thousandths and 7/10. If this is more precise than your specifications require, you can round the figure up to 557 thousandths. The same basic technique is used for making readings on depth mics, but there are certain important differences. First of all, the design of the depth micrometer is somewhat different. Instead of a semicircular frame, it has a base which forms a flat T surface. This allows the depth micrometer to be positioned flush against the reference surface. The rod, like the spindle, is also adjusted by the thimble. But instead of moving against an anvil, the rod is adjusted until it stops against a second surface, which is lower than your reference surface. Another important difference between these two mics is that you read their barrel scales in the opposite direction. The scales on depth mics are graduated in the same units as the outside mic, but the graduations increase in the opposite direction, so that the covered rather than the uncovered graduations determine the measurement. 0 is at this end, And counting by 100,000ths, we reach 1,000 thousandths, or 1 inch, at this end. This is the opposite of the way the scale reads on an outside micrometer. That's because the depth mic is indicating how much the rod is extended into a depth as opposed to the outside mic, which gives an indication based on how wide the spindle opens from zero in the closed position. Depth measurements are obtained using the same principles as measurements on the outside micrometer, although with a twist. First, the total reading on the barrel scale is determined, but, and here's the difference, keep in mind that the barrel scale is read in the opposite direction. Then the indication on the thimble scale is added to the reading on the barrel scale. In this case, to determine the reading on the barrel scale, we need to identify the number that is uncovered to determine the covered number from which to calculate the reading. We can see that the 500 thousandths graduation is visible on the barrel scale. This means we can start calculating the reading from the 400 thousandths graduation, which has been covered by the thimble. Next, we need to calculate the first 25 thousandths graduation that is not visible. We can see the 50 thousandths graduation between 400 and 500 thousandths, which means that the 25 thousandths mark is the first graduation covered up by the thimble. So calculating from the scale indications that have been covered by the thimble, we have a total barrel scale reading of 425 thousandths. Next, the reading on the thimble is calculated. In this case, 19 thousandths lines up with the reference line. Just as we did with the outside mic, we add this reading to the barrel scale reading to determine the total measurement. 400 thousandths plus 25 thousandths plus 19 thousandths equals a measurement of 444 thousandths. There is no vernier scale on depth mics, so when the thimble scale falls in between graduations of thousandths, approximate to the nearest thousandth. Here is another depth mic measurement. The number visible on the barrel scale represents 900 thousandths. Consequently, we calculate the measurement starting with 800 thousandths. Next, we can see that 325 thousandths graduations are visible from the 800 thousandths division covered by the thimble. Therefore, we calculate the reading from the 800 thousandths graduation. On the thimble scale, the 21 thousandths mark lines up with the reference line on the barrel scale. 21 thousandths added to the barrel reading produces the complete measurement. Adding 800 thousandths plus 0 thousandths plus 21 thousandths, we determine that this hole extends 821 thousandths from the surface of the object. As you review the material we've covered today in your study guide, make certain that you know how to read the scales on a micrometer and that you understand its operation. In our next lesson, calipers, you'll see how another common mechanical measuring device is used to take inside, outside, and depth measurements.